What's going on, guys? Xiangqi here. So we continue our work on Deobfuscated, world's smallest chess program written in JavaScript by Oscar Toledo. And in this video, we're gonna be figuring out what are these variables all about. So the most essential array that we will be working with in this video is this array marked with the L letter. And what I can say for sure about this array that it does contain at least three types of variables. Yeah, so just update and just run it a couple of times. Okay, the couple of times just because of scrolling capabilities to give an idea here. So, sorry, we have the piece codes in the beginning. For some reason, I'm not sure why exactly they have they been initialized here. Is this a side effect of the general initialization routine, or sorry guys, or maybe it serves somewhat a different purpose? I didn't yet figure that out. But anyway, we have actual piece move offsets, like let's say for white pawn right over in here, let's say like diagonal capture one side, another side, single pawn push and double pawn push. And for other pieces it should be the same. And also variables like values like this, as I've revealed so far before, well, during the preparation to this video, so they reference in the index of where we should go. So let's say here index of 53, so we just go here, and this is probably the offset for a knight, or I'm not really sure which piece in particular, but yeah. So that's the idea. So I've counted up to three types. So the move offsets, the indices pointing to where the move offset for a certain given piece type starts, and the piece codes. So I'm not sure whether the piece codes I used has been mentioned already, but this is enough. This is already enough information to actually continue with our deobfuscation. So based on this idea, and bear in mind the fact that, well, from my perspective, I would say that the most essential usage of this array is here, exactly where we do initialize the target square, and also it involves the iterating over the attack rate for sliding pieces. So here we need to take this L array and index by the C, which is the index pointing to the certain element within the array where we can find our move offset. So let's start by renaming this L to move offsets. Okay, so just want to find this. Let's go for exact match, and I don't even know where it's, so yeah, it starts, seems like it starts here, and yeah, Control H. So let's go and try to rename this at first. So L, let's call it move offsets, and go into next and replace next, and replace next, and that's pretty it, right? Yeah, not, oh, oops, I'm sorry. So here as well. Okay, replace next. I hope I didn't miss any. All right. Yeah, seems like. Okay, so if I didn't break anything, it should still be capable of playing chess. Let's quickly check that out. Okay, so we are still capable of playing chess, which is good news. Okay, and another thing I want to do, so thankfully to the JavaScript syntax options, we can go this way. So I just want to put the variables one after another when they're being defined. So here, let's say move generator. Well, just say variable definition. Well, mostly it's the move generator variable definition, but search as well, so I can't just claim that these are the move generator variable definition, and I would rather be given some extra information for each variable here of what kind of purpose does it serve. Okay, and yeah, so yeah, this is the condition of for the next iteration of a for loop, I believe. Might be not, I'm not sure yet. Okay, but anyway, okay. Oh no, it's not there, it's probably here. Oh, or not, just a bit shift. Okay, I'm not sure at the moment, so we actually don't care about this at this particular moment. Okay, so save, and I really hope to see still plays chess. Cool. So now let's move the commentaries from this part a little bit. So here we want to take move back to restore board position. Okay, make move on board. Okay, so now here is the description for moved piece. Okay, captured piece. Save, and let's say this is a source piece, and this is whatever piece occupying the target square before move was made. Okay, target square. Let's say we don't need this. So target square is the square where the source piece is gonna land. It's gonna land on. Okay. I'm not sure about this part. This line, source piece, a current piece to move, to generate moves for. Okay. This end with a minus infinity, not sure yet what that does. So let's go for source square. So square counter intended to keep track of to loop over the board squares. I just don't know what's the better way to say this. Let's say square counter. Let's say even board square index holder during a loop over board squares. Well, in Micromax by Harngert Müller, the loop over the board squares, over the piece offs of the move offs, over the move offset, and over the attack ray within every single move offset for sliding pieces to our list is separated to three loops. Explicitly. However, Oscar Toledo goes for very sophisticated hacks and does seem to have only 2 loops. So the first one is actually this loop, which is a loop over board squares, and this loop, let's say loop over board source squares, and here loop over board target squares. And the matter of whether this is the sliding piece or not, so we want to break out of the loop of like through the attack ray, like square by square. This is done implicitly somewhere here, and we don't have that kind of explicit separation of just having like the loop over move offsets. So we'll now figure out how it works. So this is a little bit overwhelming for me at least, but yeah. Okay, so here, yeah, let's give it a bit of a space. All right. Okay. And here we do increments or square until reaching, let's say we know what the particular square it is. So this is square number 89. Yeah, 89, and this is A, B, C, D, E, F, G, H. So reaching square H1 index equals to 98. Well, this is explicitly clear from here, so H1 is just enough. Okay, to square, so we're square until reaching square H1, and yeah, and starts from 20, but then it gets incremented, so it literally starts from 21. I've been showing you this in the previous part. So from this one, from 21 here, and A8. So starting from A8 and going to H1. Okay. So yeah, now let's go to the most interesting part. So can I put this commentary here? Yeah, I guess I can. Or no, maybe I'd better don't. Okay, just make sure everything's still working. Okay. All right. Yeah, by the way, I finally changed the hotkey for starting my video recording software. So now if I press Ctrl R, video recording doesn't stop anymore, as it was like a real disaster in the previous part. So hopefully those kind of issues not gonna be faced anymore. Okay. Okay. So move offsets, and now the move offsets has been indexed by this C. So let's try to figure out what the C is, and the C should be a certain move offset that we're currently dealing with. So let's say console.logs. Just want to show you this as an example. So let's disable our recursive call and go for printing. Yes, enable this one. Make, move, and take back stuff. So here, yeah, by the way, hold on a sec, we don't even need that at the moment. We can just print, let's print the piece, so the source piece, and let's say pieces to just give it a Unicode character, and then plus, so let's say just like, so piece and whatever we got there, and offset, the current offset we're going to be dealing with, and put the C. Let's have a look. Okay, so, and here we go. So you see, like we have, we do ignore the black pieces. We'll soon figure out how the logic of ignoring the black pieces is done. So distinguishing just a piece by the color that belongs to the side to move. So now it's kind of white to move, and we'll only generate moves for this white pieces. If this was black to move, in that case, would be generating moves for black pieces. So just, well, actually it's reversed because there is a piece of code responsible for that. But anyway, the case is, yeah. So in this case, okay, in this current particular situation, it doesn't seem to be printing the correct offsets, but that's probably just because I'm calling this search and run way without, yeah, probably to make 100% sure that it's gonna be working. I need to disable this exact thing. Not sure. Let's have a look. No, it doesn't help, but well, guys, I'm not sure why it doesn't work properly for black currently. No idea, to be honest. But at very least, this is enough to be working for whites. So, oh my God, what the heck is? Can I just update, please? Nope. Okay, did it break something already? Oh, it's just, hold on a sec, this is just an offset, so this is correct. Oh my God. So we need to say, yeah, this was just a matter of the move offsets. It was working actually properly. So move offsets, sorry, I just got fooled here. So move offsets indexed by C. So literally what we do here during the initialization of the target square, or next iteration within this loop over target squares, literally like over squares along the attack ray specified by the current move offset. So I think that's more or less a reasonable explanation of what's going on here. Yeah. So yeah, let's have a look one more time. So let's go for white. Yeah, and these already seems like the reasonable offset. So double pawn push, single pawn push, pawn, pawn, yeah. And the knight moves, okay, and let's try, now this should be also working for blacks as well. Yeah, we have the opposite offsets, which is absolutely fantastic. So we have the knight offsets, okay. We have the double pawn push for black, single pawn push for white, and so on. So these are the exact move offsets that has been used for a certain piece type. And this is important because here we're dealing with the piece types, which would come more clear soon. Okay, so what else to consider? So we don't want this stuff anymore. Well, I can just leave this for a while for those of you who want to be inspecting this particular section of the source code, if anyone is interested. And now let's see what the C is. So as we saw earlier, so let's say so before the offset, let's also print let's print offset index, so it's where to look for the offset within the move offsets. And here plus the C, right? Yeah, it's still called C. That's okay. So let's have a look. Y pieces. So here is what we got. So let's say like for this night, we have the offset index of 54, and there's the exact index where we have this certain night move. Okay, it's a little bit strange why it generates -21 for. Oh, hold on a sec. This should be generated for a night. Oh, that's because. Okay, this is how it should look like. Yeah. So, nope. Sorry guys, just feels a little bit weird. Oh no, it's not weird. It's probably, yeah, because we just here we increment this. Yeah. Okay, so can't say for sure. But just want to give you, so let's not inspect this one, probably some, I don't know, specific case or something. Let's try to inspect, let's say this one. So night, move offset index 64, and let's say move offsets yeah, move offsets index like this. Yeah, 54. So if we just inspect our move offsets, and let's go for index 54, quite naturally we'll find this value of -19, which is one of the night offsets for one of the black nights, for both of the black nights basically. I'm not sure whether this is the exact one which is used here during the move generation, but anyway, this is a matter of night of the piece type. The night piece type has one of the offsets it has is 19. I guess this -21 is also night, and this should be the night as well. Not sure about the others, so yeah, we'll see. We'll see later on. Doesn't matter doesn't matter at the moment. So the reason why I was explaining this is just to give a proper name to this C variable. So this big C, so here we want to initialize move offsets index pointing to where let's say pointing to a certain move offset depending on a piece type. So let's call it like this. And now respectively, so you need move offsets index. Let's say not the move offset, let's say init source pieces index, init source pieces. Nope. Move offsets. Move offset. Okay, let it just be like this for now. Maybe I find a better description for this. Just hold on. I'm sorry, just got an eyelash in my eye, guys. Sorry. Okay, so let's see where this C occurs. So find and Control H, and starting from here, I guess, right? So I want to replace this with well, let's call it offset index, or move offset index, even move offset index. So next, replace, yeah. Yeah, can replace here in the commentaries. And one of the most essential things, so we'll now figure out what this does. It's no matter how the slider pieces loop over the tag race is being maintained, while the leaper pieces gets dropped from the loop. So yeah, okay. And I think this is it. So let's see if we still, okay, now it's just not working, because yeah, let's re-enable this stuff. Let's re-enable, well, probably before, no, let's re-enable straight ahead. Let's re-enable first, because if something goes wrong, then we want to figure this out on the early stage. Okay, still working. Okay, yeah. Any other moves? Okay, so then what? So we have move offset index, and now yeah, a very interesting thing is how is this index being calculated. So here is the condition, and so you select moved piece is like well, the moved piece might be, as we already know, it might be either the source piece or the pawn in case of, so when we promote to queen and then drop piece back, it shouldn't be queen, it should be pawn again. So that's the reason of having a separate variable moved piece instead of just the source piece, which is source piece here, which is just a current piece to move, to generate moves for. So anyway, the moved piece is the source piece at the same time, just a matter of restoring, so just forget this. Okay, so the moved piece is the piece that we actually move. The current piece that we're generating moves for as well. Okay, I'm saying gibberish apparently, but okay, I've been explaining this in the previous part of the list. So -9. So this expression might be either true or false, but let's try to figure out when exactly this would be false, right? So this should be equal to 0 to be false, and the only case where this is possible is for white pawns, because we have 9 only like for white pawns. So if we have the moved piece equal to 9, and we say -9, this would be equal to 0, and that's the exact case. I'm not sure why exactly that is done, but apparently because of the direction, because white pawn, so we have like all the directions, like from the starting index to the ending index, like this, well, at least from the pawn's perspective, and only so all the other pieces are symmetric, and only the white pawns are kind of going against the flow, let's say, right? So I guess that's the point. But anyway, that doesn't really matter that much at the moment, because it's just a matter of what kind of move offset index we pick up in this case. So we will pick up an index of 49. So let's inspect this. If we just go to the move offsets and the index of 49. So here it is. So -11, -9, -10, -12. So we have two diagonal moves, one pawn push and single pawn push, and then the double pawn push. So these four values are the exact move offsets for white pawn. So I hope that's clear. Okay, what else? So in other case, for all the pieces other than the white pawn, I'm not sure why exactly this is done like this, but anyway, we have a constant of 61, which is the offset within the move offsets array, and we also need to plus the g. And now a very interesting thing to figure out is what the heck is g. So the g is a piece type, and I will now show you how in particular this can be revealed. So here, let's say console.log, and just say the piece type, and plus g, save, and let's start again, and here we go. So you see, like, we have 5 3 4 6 2 4 3 5 1 1. So type of pawn is 1. Okay, type of rook is 5. So you see, like, if you just take these guys and put them like here, you'll see the rooks, rook here, bishop here, sorry, knight here, bishop, queen, and king. For both sides, we have the same. And now, in order to figure out how the type has been extracted from the piece code, it's another interesting thing to consider, and where exactly this is happening. So this is where it's happening. So probably it might be on the cards to I don't know, this is possible to not ruin anything like this. Well, this part actually distinguishes whether the site to move and piece color actually matches, and I'll try to show you how this works just in a few moments. For now, I just want to figure out how exactly can we specify the commentaries here. So okay, so let's start. So here we want to initialize the moved piece, target square, moved piece, and target square. Okay, so moved piece is whatever the board indexed by the target square, and target square is on the fly initialized to the source square. And later on, it would get updated. Oh my god, where that's happening? Here it gets updated incrementally. Okay, and well, let's put this commentary. Yeah, let's put it back, and I'm not sure if this is a good idea. So here we want to initialize piece type and pick only those only, let's say, pieces that belong to the site to color. Oh my god, that's too long. I want to shorten this. Okay, so maybe what if I hold on a sec? What if I say let's say need moved piece to whatever available at target square, and here sorry, not here, but here initialize target square equal to source square. It will get incremented later on. Okay, so here you need the piece type. Here, yeah, because of the fact that the code is very obfuscated, it's hard to put the commentaries in a reasonable way. And here let's say use only pieces, use only those pieces matching current site to move. Yeah, this should be okay. Yeah, so now we'll see how exactly this kind of works. So yeah, and by the way, so we just don't. Well, as far as this, or hold on a sec. Yeah, it's a bit tricky to explain. Why do we actually get into this loop for black pieces? It feels like they shouldn't be displayed at all, but they actually won't get displayed here when it comes to the real sort of so yeah, probably so let's make it like this. Let's make it like this. So now it should be displaying only, yeah, so piece type 2. What the heck is, yeah, this is it. Piece type 4, 16, piece type, oh my god, piece type 2. Maybe the G's. Okay guys, I'm sorry, just let me just keep the G here, because I don't know, maybe it gets altered somehow. Yeah, it gets altered here. So it's kind of gibberish after. So let's better print more information that we don't need rather than having the malformed information. So here are the piece types. And I just want to bring a bit of a light on how this piece types are getting extracted. So this expression is absolutely essential. So this is the expression to extract the piece type of the piece code. So moved piece holds the piece code, and site to move might be either 8 for white pieces or 0 for black pieces, as been mentioned before. So let's just have a quick look. So here, let's say 9 white pawns. So this is 8 in binary, this is 9. I'll use the calculator to make sure that my calculations are correct. And I now want to XOR with white. So 8, this is 8 in binary. So in this case, this should be the case. I mean, this when it's white to move. So we want to extract the. Okay, let's just. I'm going a bit forward. So let's go step by step. So 1 XOR 1 would be 0. 0 XOR 0 would be 0, and 0 here and here 1. And we have 1, just to show you that this is the case. Go into binary and 1, which is, by the way, should be 9. Yeah, should be 9, right? XOR with 8, and we have 1. Okay, so here is the type. Here is the type for white pawn. So you might be wondering, how do I know that this types? So we have this white pawn here, and let's try to do the same for black pawn. Let's try to say, so this would be like this, and again, like this is gonna be working. So for whites, oh yeah, just another thing to consider. So let's say we do the same, but the site to move is black, and in this case we have exactly the same value, and this is gonna be 9, and this fails the condition that this expression should be less than 7. So it's not less than 7, hence we're not going to be picking up that sort of a piece. Okay, so I hope this is clear. So this kind of piece type extraction would only be working, working all of the time. It would be, the piece would be considered only in the case if the site to move actually matches. So here we have the white piece and we have the white to move, and hence we're gonna be using this, otherwise we don't. And the same for blacks. So here, well, I just remove this later on, but for now, piece would be picked up, right? And here won't be. Or even let's say, yeah, let's actually say white to move. So this is the case for white to move, and this is the case for black to move. So here it won't be picked up because this value is greater than 7, and we need it to be less than 7. Okay. Oh my god. So here we have the opposite scenario, and here, so we just XOR this value with this one. We'll have this value, and this is the black to move, and otherwise, so this is gonna be so this point is gonna be used because it's black to move, because we have 1 less than 7, so we go ahead. And otherwise, other scenario might have been like this, and XOR with 8, which would result in 9, if I'm not mistaken. Yeah, should be. Let me quickly check this out. It should be the case. So 0 0 0 1 XOR 1 0 0 0, and it should be 9. Okay, so 9 is not less than 7, hence the piece is not going to be picked up. So exactly the same thing as we had for the white pieces, but this is just for the black pieces. And now let's take, I don't know, let's take 10. It's a kin, for instance. So this would be like 8 plus 2. This is going to be 10, right? And XOR it with white. So what is going to be? So 1 XOR 1. This is 0 0 0, and then 1, and then like this. And this is 2, and we have type 2 for kin here, and the same would be here as well. So here we have 2, which would result obviously like just has been shown. So like this, and like this. So here is the kin, here is the black kin type, here is the black kin type, here is the white pawn type, the white pawn type. So one last thing to consider. So this is the white pawn type, the black pawn type, black king type, and here we have the white pawn type, and here we have the white king type. So now again, like, so I hope now it's clear how I know the why this values match to the exact piece types. So this is, I've just shown you the way, guys, of how you can manually can extract the type using this XOR bitwise operation. So you can apply this to whatever piece, and eventually, if you bitwise OR it with a proper color, this should result in having a value that represents the current piece type, and all the piece types have been listed here. And now, why the heck do we need the piece types at all? Okay, well, probably I can even, well, no, sorry guys, or maybe, you know what, color encoding. So yeah, let's just say examples of piece type. No, let's say piece type extraction. Okay, let it be here, piece type extraction example. Okay. I still don't like how this looks. It's pretty useful information, but do I provide some extra commentaries in the source code for this? Well, not that. Well, it is, but it's not really that seen that clearly. Piece type extraction. Yeah, let's keep it like this. Piece type extraction example. And oh my god. So let's say oh man, no. Okay, so this is the black king and this is the black, and oh no, it's already. Oh my god, guys, yeah, just okay. You know what I mean. I don't want this crap to be here. I'm sorry. Just get rid of this. It annoys me so much. So I hope that the logic of extracting the piece types from the piece codes is clear. I need to say that in Harm Miller's implementation of his Micromax Jazz engine, this is done much easier. We just need to bitwise end the first 3 bits, like 3 rightmost bits, which result 7 at very most, right? With 7, right? Yeah, with 7 to extract the piece type. But here Oscar Toledo used a bit more obfuscated and a bit more sophisticated way of distinguishing the of extracting the piece type from a current piece. So I'm sorry, probably I've spent too long on this. So I just wanted to give you an idea why this G variable should be treated as the piece type. So let's search for a G variable and let's replace it with a piece type. Piece type. Okay, so starting from here, next, replace piece type, piece type, piece type, piece type. Piece type, piece type, piece type, piece type, piece type, piece type. Okay, right. Okay, and now let's make sure that the engine is still working after all this stuff being done. So just comment out this line. I will get rid of this debugging lines later on, but for now I think we can use it. And yeah, by the way, so here is one of the essential points. So we take the offset of 61. So let's have a look at the L. Oh no, it's no longer L. It's move offsets now. And 61, 61 starting from here. So you see, like before, we have some actual move offsets, and here we're starting from the 61, from the index of 61. We have the numbers that are actually the indices where the certain move offsets takes place. So 45 points here, right? Like 39 points here, and so on. So for every piece type, this should be the case. Okay, so I hope this is clear. Let's move on. So what else do we need? Yeah, now let's make sure that this is still kind of working. Yeah, let's have a look. Yeah, seems like. Okay. All right, so yeah, this is good enough so far, I believe. And probably we end up for this session at very least, because I think I've already exhausted the amount of things I've been preparing for this particular video. Just want to make sure. So this A holds. Yeah, this is another interesting variable. So it's just either either 8 or 4 offsets for a certain piece type. So yeah, this is going to be probably the very last thing to consider. So if we have a look at the move offsets again, so let's say go to somewhere. So let's say this one. Nope. Yeah. I'm not sure which one in particular this is, but this might be a rook, let's say. And by the way, yeah, it doesn't matter even. So let's say these offsets are valid for a rook. So we have -1 goes left, +1 goes right, -10 goes up, +10 goes down. So yeah, this is how the rook is going to be moving, and we have exactly 4 directions. So this is the number of directions. Okay, so I just was trying to figure out what's the proper name for that variable. So the number of directions. However, if we have a look at the knight, so let's say, I'm not sure whether this is the knight. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, this should be. Or no, hold on a sec, just a bit. Probably this is the knight. Yeah, because this should be symmetric. Yeah. Again, I'm not sure that if this is the knight offsets in particular, because I don't remember them by heart that nicely. But the idea that we have exactly 8 offsets, and where else do we have the 8 offsets? For king, for knight, for king, and for queen. Okay, so let's say this value is like going left, right. Yeah, let's say so it goes diagonally, one step ahead, one step. Well, it's probably not the exact place, but just to give you an idea that for another situation where when we would be having like up to 8 directions is the combination of the orthogonal and the diagonal directions for queens and kings. Okay, and for knights we have the specific case because it's just going like on its specific way. Okay, so I think that, well, this is just an assumption. I actually didn't really test this yet, and I'm not exactly sure how exactly this logic works. So let's just try to have a look. So bitwise n with a bit number 2. So piece type minus. So let's try a bit of a calculation. So let's say we have 9 XORed with a side to move. Is this the case? By the way, piece type. No, hold on. Yeah, piece type, which was G. Yeah, piece type. Again, like this is gonna be equal to 0 0 what a heck, yeah, 0 1. Okay, so the next thing we need to say, so anyway what happens here, what happens here is we want to, for some reason we decrement piece type by 1. I'm not sure why exactly this is done, but maybe we'll see now. And then we want to bitwise end with 2. I just want to manually check that out, whether it works or not. I'm not sure why this works, but just whether it works, just to make sure that my assumption is correct. So minus minus, so this would be equal to 0. Okay, so this is going to be equal to 0, and now bitwise end with 2. This is going to be equal to 0, right? Hence, we should have 4 elements. So is that the case? Oh, yeah, this is the case. So if this is true, then 8. Otherwise, this is 4. So this stuff kind of matches. Okay, let's try the keying, for instance. So let's try the keying. So this is gonna be 10, and bitwise end with this, and this is gonna be 0 0 1 0, so 2, then minus minus, this is gonna be 1, and we bitwise end this with 2, and this is gonna be equal to true. Yeah, so this is gonna be equal to 3, I guess, right? Let me just quickly check this out. So binary 0 0 0 1 and 0 0 0 1. What? Hold on a sec. Hold on a sec. What a... Oh, 1 and 0 would result in 0. Yeah. Sorry, this is not... I just messed up with 4. So does it mean that the key also has... Well, hold on a sec. This is a bit strange, to say at least. Okay, so I need to be more precise here. Let's go step by step. Yeah, but by the way, guys, this is this goes beyond my preparation, and what I'm currently doing is actually how my preparation for this live streams kind of looks like. Yeah, so okay, let's go again. So the keying should contain, it should contain 8 directions. Maybe they just do it a bit different way. So okay, let's try 11 instead. Let's try 11. So 11 should be like this, right? Yeah. So binary. So what do we do here exactly? Again, one more time. Piece type minus minus. So first we do this decrement. But to extract the piece type, oh my god, where is the piece type? Here it is, move piece, and decide to move. So XOR with this one, 11, now minus, this is binary still. Okay, let's just turn it to, it's 11 in binary, which means 3 in decimal. Oh man, like this. So 3 minus 1, so decrement by 1, we have 2. And let's go back to binary. Yes, and bitwise end with Is this 2? Yeah, this is 2. And this is equal to 10, which is true. So this is the, it's not false, it's true. And binary should be 2 as well. Decimal should be 2. Okay. Yeah, it works for night. Works for night. So let's say here. Okay, how to reproduce this? So 0 XOR 0. 1 XOR 1, 0. 0 XOR 0 is 0. And here 1, here 1. So this is 3. And minus minus, this is going to be 2. And bitwise and it's going to be 2. Right? Yeah. So this works for night. And 8 directions, right? This is the pawn. But yeah, I'm still confused. So why the king? Maybe the king is treated to be a different type of piece or something. Well, let's actually try this with 14. So this is gonna be 14, right? And like this, and 0 1 1 0 minus minus. So this is 6, right? So this would be 5. 5 bitwise and I'll check this on the calculator now. Bitwise and with 2. Yeah, this already should be true. So 1 1 1 0, which is 7. So we have the offset of 8, and this is the queen. Okay, let's go for check quickly. So 14. Binary. So this should be 14. 14. What the heck is? Oh, sorry guys. Yeah, now this is gonna be okay. So yeah, 14. Go back to binary. XOR with 8. 6, right? 6 minus 1, 5. So this would be 101 in binary. Okay. And bitwise and with 1 0. What the heck is? Hold on a sec. Is this just? Hold on a sec. Maybe that's just a misclick on a calc. And 0 0 1 0. What a, oh man. Oh, did I? Yeah, I made this damned or operation again. Oh, guys, yeah, this is getting a bit strange. I'm not really sure why. I'm not really sure. Yeah, those should also be given 4. Yeah, it's a bit unclear, to be honest. Yeah, let's get something more intriguing. Where this comes from? Get something more intriguing. So, yeah, we currently should be capable of playing still, right? Okay, so yeah, let's go for yeah. I just want to print this A. So instead of assuming something, so let's say console.log, and so I consider this to be direction number plus A, and also I want the piece type. Well, let's actually see the piece. Yeah, pieces indexed by the moved piece. Okay, piece. Yeah, and this won't tell us much because we have only the knights and the pawns moving in the initial position, and they do match for my calculations, for my manual calculations. So we'll probably need to get rid of a pawn to. No, the rook actually matched as well, or did it? Didn't it? Queen. No, knight match. I didn't check the rook yet. So, yeah. Let's make a move. Oh, it's gonna be, no, it's not gonna last forever. Let's start again. Let's make it search. So yeah, we have the pawn, four directions, knight. Okay, yeah, and hold on a sec. Basically, what I've been mentioning is actually true by fact. So we have the 8 directions for queen, and for king, and for knight, as expected. However, I'm a bit confused by, so maybe, well, I'm extremely bad in math. Maybe that's the reason I would just misclick something, or I don't even know. But this is really strange. So as far as by fact, the queen, the king, it's actually results in 8, which means that this decremented piece type bitwise ended with 2 should actually be equal to true in case of okay, maybe hold on a sec. Another test. So plus and piece type minus bitwise ended with 2, and I just don't provide. So we've already done this, so I'm not going to be doing this, and I can use the piece type as is already. So piece type bitwise ended with 2. Well, and this should be given positive number for those containing 8s. What a heck is going on? Oh man. What the heck is this? Hold on a sec. What did I do? This is total gibberish because what happened to the previous? Yeah, so this guys. Okay. Probably we can say log paste and the piece. Okay, so the disaster happens here exactly. So what's wrong with this expression? It's a bit of a mystery to me, to be honest. Yeah, so the base type is being extracted properly. Okay, so just get rid of the expression itself. Oh, I guess this is the case. Let's make it like this. Yeah, that should be okay. Yeah. So true. Whoa! It actually matches my calculations. So I had 0 for queen and for king. But if this kind of results in 0. Oh, guys, I think I just got it. So this is the post increment. This is not the pre increment. So this means that probably, yeah, obviously the piece type gets, yeah, the piece type. Yeah, that's the case. So we don't, yeah. So we don't need this thing. So this decrement by 1. The decrement by 1 happens later. So this was the mistake. So we don't want this decrement by 1. And we just want, so in this case, we want like this. And bitwise end with a 2. And 1 and 0, 0. 0 and 1, 0. Hands 0, hands 4. Okay. And in this case, yeah, finally I figured this out. So here we have like this, and yeah, and 1 and 0, 0, 1, 1 and 1 would be 1. Well, this just matches by an accident, but yeah, this is still okay. So this is literally 3. Bitwise end with 2 would be equal to 2. 3 bitwise ended with 2 equals to 2. Yeah, and this is so this is not false, this is true, hence 8. And here, yeah, now we'll finally figure out what's wrong. So that was the post increment. Yeah, so it's very important that when the post increment is used, we first do the operation and then we do the post increment. So this order of operations is very important. I just thought that is the pre increment, but that was the post increment. So I just check this out one more time and then we get back to that. Okay, so like this, and so 0 and 0, 0, 1 and 1, 1, and 0 and 0, 0 and 1, 0, 0 and 1, 0. Yeah, so and hence this is gonna be 8. And now everything is matching. So one last quick check. So 1, 1, 1, 0. Bitwise ended with 2. We have 2, which is true. Okay, perfect. So yeah, finally guys, the mystery has been revealed. So yeah, I don't need this anymore. Just get rid of these calculations. Yeah, so this is extremely important point, because otherwise it's not going to be working. So decrement piece type after figuring out the number of directions, after initializing direction number, number of directions. Okay, so it wasn't with 2, either 8 or 4, and then we do this decrement. Well, I have no idea at the moment. I have no idea why this decrement is done. So probably that is needed for some purposes. For otherwise, it won't be like that. But anyway, okay, great. So we don't need this anymore. So we can just enjoy the fact of having this exact. So I just wanted to. Well, actually, I just wanted to figure out whether it's a correct assumption that this A stands for the number of directions of the move offsets to traverse. So 8 for knights, for queens and kings, regardless of color. Okay, either white or black because the piece type is the same. And for the rest of pieces like rooks, pawns, and bishops, we have 4 directions: only diagonal, only orthogonal, or like diagonal or and orthogonal for kings, queens, and the specific directions for knights. And that's kind of pretty it. So now we can safely claim that this A is direction offset number. So just while searching, I'll try to find a better name for it. So starting from here, so number of directions to traverse. So let's say offset number of or maybe number of offsets. Doesn't look nice. Okay, let's better give a commentary. So initialize number of offset direction. Initialize the number of current the number of offset directions for a current piece type. Is this the case? I need the number of offset directions for a current piece type. Okay. And here I can claim that king, queen, and knight has 8 directions, and pawn, rook, and bishop has 4 directions to traverse. Okay, probably we can give it like this. So king, queen, knight has 4 directions to traverse. And here pawn, rook, and the bishop has 4 directions to traverse. Okay. Great. So let's move back here. So let's call it offsets number. Okay. So next, and offsets number, next, offsets number, next, offsets number, replace, 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 replace. That's pretty it, I believe. And now let's restore everything back and make sure that it's still kind of working. Yeah. So yeah, I just committed it out, right? Oh, right. So just to, yeah, to make it visually more clear, I will probably get rid of this in the next part. But for now, no, guys, it's time for a cleanup. So I'm sorry, I just get rid of this console logs all on the way because they just really starting to annoy me, to be honest. So yeah, let me just quickly get rid of them. Save. Can make another line here. Okay. Still to reveal this sort of a thing. So okay. Yeah. Okay. Okay. So let's make it recursively call itself back and hold my breath and hope it still plays chess. Okay. Yeah. So I think so. Hopefully everything is still working. Great. Yeah, this was tough. So yeah, this post increments versus pre increments might be really tricky, so beware of those guys. So always distinguish between the post increments and the pre increment. Yeah, by the way, what I mean by saying the pre increment is, for instance, so this is the pre increment, this is the pre decrement, this is the pre increment, and this is post decrement. So yeah, I said post increment, but actually it's post decrement. So minus minus is decrement and plus plus is increment. So it literally means like piece type equals piece type minus 1, and if this is plus, it would be piece type equals to piece type plus 1. So increase by 1 or decrease by 1 respectively. So yeah, probably the video is lasting too long already, but I'm sorry for that, guys. That's a downside of the live stream. So when you're doing everything kind of on the fly, and especially when it goes a little bit beyond the preparation, things happen. But this makes the process even more real. So I hope I hope you've enjoyed it and learned something useful out of it. So this is it from my side. Thanks for watching. Until the next time, and take care.